Hello grade 8, let's learn about cross multiplication, how we can use cross multiplying to help solve problems with ratios and fractions. Cross multiplying is a method to verify whether two fractions are equivalent or equal, and you can just use the same strategy of cross multiplying to verify or solve unknown numbers in a ratio problem, for example. So let's have a peek here at the first example, example number 1. Okay? In example number 1, we have two equivalent fractions. We know by looking at it that 1 over 2 is equal to 10 over 20. You know that because it's just very easy and simple numbers. So I'm going to use this as our first example to show how cross multiplying actually works. In cross multiplying, what you actually do is you draw these bubbles across the fractions, from the numerator on the left to the denominator on the right, and vice versa. And then, as the name implies, you multiply. So first you draw your little butterfly, I guess you could call it, and then you multiply, you cross multiply. 1 times 20 is equal to 20. And in the green bubble, we've got 2 times 10, which is equal to, of course, 20. Now the two are equal, and so what cross multiplying has done for us here is actually verified that there are two equivalent fractions. Yes, okay. And you could also write it at the bottom here as such. Watch. 20 is equal to 20. You can set it up that way as well. This is sort of your final statement. Let's look at example number 2 now. 3 fifths and 6 over 10. Are they equal? Let's find out. As I draw my bubbles, you can do some mental math and see that, yes, of course, that's equal. But let's verify, because it's just double. You have 3 doubles to 6, 5 doubles to get 10. But let's prove it using cross multiplication. So I've done 3 over 10 from the red bubble, and now I'm going to do 5 times 6 from the green bubble. And of course, we verified that it is in fact equivalent. 30 equals 30, so we've got a verification. Good. Now let's look at example number 3. Oops, I forgot to label that one. That's number 2. In example number 3, I want you to take a peek at that and tell me if you think those are equivalent. So you probably have seen that I've made a mistake here. It shouldn't be 5 over 9. Watch what happens when we cross multiply. So 2 times 9 rather is 18, and 5 times 3 is 15. Because the answers are not the same, 15 and 18 are different, you know something went wrong. So if we back up and have a look here, okay, so if I multiply 3 times 3 to get 9, I should have multiplied 2 times 3 to get 6 here. So what we can do is fix that mistake. And so you see, you can use multiplication to verify what you did and to make sure it's correct. Change that to a 6, change that to an 18, and you're set. 18 is equal to 18. We verify. Now what happens, let's go back now and actually see what happens if we had an unknown value. Okay? So, and how can cross multiplying help us? Let's have a look when it's an unknown value. Let's see it look like this. Remember, when we have an unknown value, we usually represent that unknown value using some sort of a variable. Let's use x. We're going to cross multiply just like we did before, but we're going to try something a little different. We are going to say 2 times 9, which is 18. And we are going to say 3 times x, because we're still going to cross multiply. But the problem is we don't know what the value of x is. So what we're going to do is, just like we did over here in blue, we're going to set the two up across from each other. The left side is equal to the right side. So 18 equals 3 times x, which I'm going to write in a more simpler fashion, 3x. And then you just have a basic algebra statement. And you know how to solve that, don't you? You just divide both sides by 3. Cross those out. X is therefore equal to 6. And isn't that what we got before? 6. Voila. Cross multiplication. Okay, let's look at a problem. Polygon and Calculator are friends who competed in a math contest. Cal won first and Poly won second. They both won prize money in a ratio of 5 to 3. Cal's share of the prize was $60. How much did Poly win? So pause the video, or actually the video is about to end. See if you can solve this and check out video number 2 for cross multiplication to see if you got the right answer.